Hello, everyone. This is Amir from Audio Science Review. I thought I started a new series on fundamentals of electrical engineering. Not to teach you electrical engineering, for that you need to go to school and spend quite a bit of time learning how to design circuits. But there's a set of lingo we use in talking about audio products, in product reviews I do or discussion. And it's important for you to understand that, and also comes in handy, as I'll explain later, if you want to change power supplies and so forth, what's involved. And I get a lot of questions about that. It's not a long presentation, and my goal, again, is very specific to just make sure you're familiar with the lingo in the context of audio. And I'm going to start with voltage and current, the two fundamental components of any audio circuit. So let's get into that. Oops. Starting with voltage, the symbol for it is V all over the world, but for some strange reason in Germany, they use U over there. Very confusing for us when we look at the explanation of engineering that has U in there as the voltage. They use, I think, V for velocity. But the rest of the world correctly has standardized on V for voltage. There are two kinds of voltage. One is called alternating current, and it's we say AC. The other one is direct current, which is naturally called DC. AC is what most common examples, what comes out of your wall outlet, and DC is what a battery produces as the best example. But we can also convert AC to DC, as I'll talk about. Key thing about voltage is that it can be quite dangerous. Standard sort of threshold of when it starts to become dangerous is 30 volts, although, I think 40, 50 volts probably okay, but will give you a jolt. And as it gets higher and higher, you can get serious shock and or die. So voltage is critical to understand that concept. If you're going to get inside of a audio equipment, take the top off, it's important to identify, whether it's a high voltage device or it's low voltage, and I'll talk about this a little bit more later on. The other part about voltage is that it can cause serious damage to the equipment if you feed it too high a voltage. So let's say you have a DAC or something runs with 9-volt power supply, external one, and you replace that with a 12-volt or 15-volt or 20-volt. It might work. It might work and run hot and die soon, or it may just damage it immediately. So it is extremely important that if you're going to change a power supply or mess with something there, that you match the voltages. That if the device says I want 9-volt, you give it 9-volt. One of the things I do is that whenever I have a device that becomes obsolete or broken, I may throw out the device, but I always keep their power supplies around. And when I need a power supply with the right jack, I go in the box with 100 different power supplies in there, looking for the right voltage. Current I'll address in a second, but voltage is the first thing you want to look at. And of course, if it's an adapter, you want to make sure the connector matches on that. If you have too low of a voltage, you can't damage the device, but it may not turn on, and it may turn on and act flaky. It may get stuck in an infinite loop where it tries to turn on and turns off. So again, best to stick with whatever voltage that you need to have for the device to operate that the designer assumed. Nothing runs, almost nothing runs on AC in audio devices. I guess if you have a turntable or something like that and it's got an AC motor, that may be one of the exceptions. But the number one thing we need to do in any audio device is take AC and convert it to DC, and that's the thing that drives electronic circuits. This is the job of a power supply, which I'm sure you're familiar with. Power supplies can be internal to a device. I prefer that for most devices because then there's just an AC cord that comes out and I don't have to worry about a big wall wart sitting outside. In that case, AC is actually going inside the device, and therefore the inside of the device can be quite hot and quite dangerous. So that's one of those cases where you don't want to just open the top and start touching things. Even if it's unplugged, it can cause serious shock. So be careful about that. But it can that AC can also come in the form of just stepping it down. So this is an example of a step down transformers, as you probably have seen. These are quite heavy. Whenever they're like this, almost always they're AC, although there are some that are DC output, but it will say on the back whether the output is AC or DC. And if it's just AC, like this one is, it just has a transformer, and the turns ratio primary to secondary determines the whether you can whether stepping up or stepping down. It always steps down for audio circuits. So that's what these are. They're becoming much less common these days, but this is actually from a new top-in DAC, top-in headphone amp that came with this power supply. So they do exist, but they're less common. It can also be DC output. Most common is the USB chargers for your phones. They put out 5-volt DC in the form of a USB plug. And generally, though, this is not used as is. Internally, a lot of audio devices require multiple voltages, not just one. So they take either one of these outputs and then convert them again to whatever they need. And/or they may clean up the output of this thing. This is designed to be pretty cheap, and you may need much higher precision power supply inside. That's less noisy and what have you. Excuse me. Careful in swapping one for the other. So if you have an AC input device, don't replace it with a DC one. Because first of all, these things are not exact. They don't put out an exact voltage. So while this says 5 volt, even if you got a transformer that puts out 5 volt, that's just nominal. If you actually measure with no load, maybe 6 or 7 volts. And generally, you don't want to feed devices designed for DC, for AC input, feed it DC, and vice versa. So don't mix the types. I don't want to get into complicated discussion of when it can work. It is possible for it to work, but at high level, don't confuse one for the other. A lot of audiophiles are anxious to quickly change their power supply for a better one. Fine, if it's a DC one, you have many choices. But the moment it becomes AC, you cannot change this with anything else because this is not a complete power supply. It's just a step-down transformer. The rest of the power supply is internal. Okay. Now, there are 2 types of power supplies. I've been showing you the 2 types. This is half of one. There's a linear power supply. Linear ones means you have a transformer that steps down the voltage near what you want. And then what we have out of this is a sine wave that's still going up and down instead of being a flat line. So we run it through a set of components called diodes, which I'll cover in a future video. And what these diodes do, instead of having a sine wave that goes positive, negative, it'll flip the negative to the positive. So it goes positive, 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 positives. And then that's still not DC. That's still, like camel's hump. And so we use a capacitor, which I'll talk about in another video, to get rid of those valleys in there, and we get something approximate to DC. They are very simple, trivial to design. I think I designed the first one when I was, built the first one when I was 7 or 8 years old. It just goes back, decades, and very, very simple to build. Switching power supplies are newer and much more complicated. Even something as small as this has got a lot of fancy circuits in there. And the way these things work is that they take the high voltage AC that's coming in right here. First thing they do is convert it to very high voltage DC, just the same process that I just talked about, but no step down. And then they'll switch they convert it back to AC. Why do they do that? Because 60 hertz requires these kind of giant transformers. But if you run this thing at 30 kilohertz, 50, 100 kilohertz, or even more than that, then the transformers shrink, and you're able to build a power supply that puts out a good bit of power in such a small size. And so you get efficiency, they get smaller. There may or may not be issues with them using them in audio equipment. A smart designer can make either one of these work, and they have pros and cons in there. I made a mention of this earlier, that your devices do have secondary and tertiary and even more regulations internally. So don't assume just because you can go get another 5-volt power supply that's much bigger and fancier and costs $500 that you're going to get better performance internally. Most likely, if the device ships with this, I measure it that way, and if I show you fantastic measurements, means you don't need to muck with this thing. The same dirty external power supply is good enough, and it's good enough because internally they made sure they clean, they wash the dishes multiple times to get them very, very clean. Then some people say when they see an internal power supply, then they think, okay, I'm going to go clean up my AC or use a better power cord. I've covered and reviewed tons of these products. Not one makes one iota of difference in the output of your audio device. So why? Because we already go through multiple stages of conversion and rectification and filtering in the power supply, in the audio device. So these things are almost universally a waste of money and money and equipment and space that you allocate to them. I always stay with the power supply that every device comes with. Never ever bother with anything different. When I'm testing, few times I've tested, I've got higher end lab power supplies and other things. I just don't find a difference between them. So what matters is the design of your audio product, and if it's designed well, it's immune to these kind of vagaries. So that's voltage. I'll come back to a little bit of voltage later on, but let's talk about current. Current is not the same as voltage, even though it pairs with it. By itself is not dangerous. So I could have 1,000 amps battery, I said 300 amps in here, for example, and you touch one of the terminals, nothing will happen if the voltage is low. So a 12-volt battery in your car is massive. If you short it, massive amount of sparks come out and heat and everything, but if you just touch it, nothing bad happens. Whereas if you touch these terminals when they're plugged into the wall, you could kill yourself. So very different than voltage. So too much current is not dangerous by itself until you short it out. If you don't short it out, it's very, very harmless. Unlike voltage, you can have too much current and it's perfectly fine. So let's say, you got this 5-volt, 1 amp power supply that your device came with and you lose it or you want to upgrade it. You can get a 5-volt, 3 amp one, 5 amp one, 10 amp, 100 amp one. It doesn't matter. The device only draws what it wants. The 1 amp is not jammed into his throat. Indeed, if it comes with a 1 amp power supply, it probably uses a lot less than 1 amp. It may have been the cheapest one they could get was 1 amp. You could measure the current. There's an ammeter you can use to measure current. Just do not worry, do not sweat the details of that. A lot of times I get questions on a forum. People send me messages. I found a 24-volt power supply, and instead of 5 amps, it's 7 amps. Is it safe to use? It is absolutely safe to use. If it's compatible, if the voltage is the same, and the connector is the same, do not worry about it. Basically costs you more money for more current and more size and potentially less efficiency, but otherwise it's fine. So know that current is drawn as needed. Voltage is always used all the time at full amplitude. Okay. If you have too little current, that can be a problem. Like I said, this may be a 1 amp one, and you go find a 0.5 amp one, you plug it in. The device may do one of many things. First, it may not power up at all. It may not do anything. You plug it in and it just stays dead. Or it may look like it wants to power up and it shuts down. Usually there's an initial surge of current that it needs, and the quiescent current, the runtime current, is actually lower than the initial surge. And so you need that extra current for it to start up. If you don't have that, sometimes you can get in a infinite loop if it's a microprocessor, like if you have a Raspberry Pi, single board computer, if you have too little current, it may start and shut off and start and shut off, start and shut off. So whenever you see that cycling, that probably means that. By the way, don't let it keep cycling. That is not good for it because it creates surges and everything that could damage it. But typically nothing terrible happens. So if you need a 3 amp 9-volt power supply and all you can find is a 2 amp one, it's worth a try. You can plug it in quickly and see if it powers up, and it may run because, again, the device doesn't need all that current. That's rated for the maximum. Okay? So we've talked so far about concept of bringing power into a device, but we also have devices, audio devices that generate powers of their own, and amplifiers are one of them. Funny things about power is that the formula for power is I times V, so voltage times current. So at the same time, it appears to rely on both of those factors at the same time. In reality, that's not the case. It's sort of a parabolic kind of thing, in that if the impedance or the resistance or the load itself is high impedance, it likes to have more voltage before you can get the power that you want out of it. If it's low impedance or low resistance, then it wants more current. That exact point where you go from one to the other is design dependent and power dependent. But as a rule of thumb for power amplifiers, for 8 ohm speaker loads, let's say, or even higher, if you have those kind of speakers, then the voltage for the amplifier matters more. So there are amplifiers you can buy where you have to provide the power supply yourself. And let's say you provide a 36 volt power supply for it, but it accepts also 48. You want to get the 48 one if your speaker impedance is 8 ohm or higher. Turns out most speakers I test are 4 ohm and lower. That means they want current. Now, that doesn't mean that they want current and no voltage, but strictly speaking, you need to have more current. So a lot of people are confused thinking that if they have a more higher current amplifier is better for any load. It is not. Remember, current is used as needed. So if you have a high impedance load, it doesn't matter if the amplifier can drive 5 times as much current. If the load is not pulling that current, it's immaterial. For headphones, headphone impedances can go way up to 600 ohm, even 1 kilo ohm. Generally, if I were to pick a number, would be around 50 ohm. Anything higher than 50 ohm likely is voltage limited. So if you get, for example, a phone dongle that you get as a headphone adapter, those things are almost always voltage limited. They only put out 1 volt, for example, the really old crappy ones. The decent, semi-decent ones put out 2 volts, and that's good. Then the very nice ones put out 4 volts. The more voltage they put out, the better they can drive high impedance headphones like a Sennheiser HD 650. That's a 300 ohm impedance. It wants voltage. It doesn't matter if you have 10 amps powering it. It wants voltage. So if your output voltage of your dongle is only 1 volt, good luck. You're just going to get a very faint sound, and it's just not going to get loud. The bass is going to be lousy. Okay, so for this reason, when I do my headphone amplifier testing, I show that 32 ohm, and I also show that 300 ohm. So one emphasizes voltage, the other one emphasizes current. Okay. This is a very advanced topic. It's something electrical engineers know, but you'll hear the lingo from us occasionally. I sometimes say to my reviews, there's a notion of what is a voltage source. An ideal voltage source is something that puts out a voltage, and no matter how much you try to drag that voltage down, it will not come down. What that means is that if you have an amplifier that's a voltage source, if you keep lowering the load impedance and make it smaller and smaller, you actually get more and more power. So when you go from 8 ohm to 4 ohm, you double the power. You go to 2 ohms, you quadruple the power. If you go to 1 ohm, it goes 16 times the power. It keeps doubling the power, 8 times more, and it keeps doubling up forever. In reality, we don't get that because building such an amplifier that can sink so much current is very hard to impossible. So at some point, the voltage actually starts to sag, and you don't get that ratio of doubling. I showed this when I test headphone amplifiers, in that I start from 300 ohm load, 600 ohm load, go all the way down 12 ohms, so very wide range. And typically you see in here at the end what happens with these top 2 loads. Usually from 600 to 300, headphone amplifiers don't care, basically stay perfect voltage source. Some of them will stay perfect voltage source even down to 50 ohm, but usually around that point, the voltage starts to drop, it sags. So you don't get a doubling of power. You start to lose that doubling with every bit in there. So The most perfect headphone amplifier would be the one, again, that the voltage never changes. And if it did that, going from 600 to 12 ohms, you get 50 times more power, which is unreasonable to expect. But, you know, just remember that's what this means. If somebody says, well, this thing's acting like an ideal voltage source, means that no matter how much you try to draw from it, it stays put and it doesn't drop its voltage. In audio, the transmission mechanism from one component to the other is through a voltage source. So your source, let's say it's a DAC driving an amplifier, it puts out, let's say, 4 volts, and it will hold that 4 volts, and that is what transfers a signal into the other one. The current is negligible in that case anyway. So, and same with the amplifier to the speaker, it wants to be a voltage source if it can, okay? There is such a thing as a current source. It doesn't have this kind of user visible feature. It's used in designing electronic circuits for biasing purposes and so forth, where you'll create what's called a current source, which is opposite of voltage source. It always maintains the same current, but it's not something you're going to see me use or talk about. You know, maybe when engineers talk about the circuit design, you'll hear about that. But otherwise, it's not something that you're going to see. So this is it. I wanted to keep this presentation short and sweet, where just get you introduced to these things. And then in the future videos, I plan to do videos on what is a capacitor and what is a resistor and transformer and diodes and so forth. Not sure how far I'll go down that path. But again, my goal is that you'll have an understanding and a sort of a reference for these concepts. Otherwise, you won't be able to fully follow what the you know, the reviews are saying, or what the technical people are arguing with each other. Okay, put in a comment how you like this, whether you like to see more of these things or not. Otherwise, I'll just go back to doing more reviews. Okay, see you in a future video. Bye-bye.